This question deals with the ideal gas law. So question 8.83 reads, a 2-liter container is filled with methane gas, which is CH4, at a pressure of 2,500 millimeters mercury. I'll point out that there are 4 significant figures in that number because there's a decimal here. Anyhow, you get the idea. There's a decimal there. In a temperature of 18 degrees Celsius. How many grams of methane are in the container? So let's write down what we know. We know that the volume is 2.00 liters. Our pressure is 2,500 millimeters of mercury. I'm going to convert that into atmospheres using this conversion factor that 1 atmosphere is equal to 760 millimeters of mercury. So those are going to cancel out, and I'm going to get 3.289 atmospheres. So that's done. So that's my volume, that's my pressure. My temperature is 18 degrees Celsius. Of course, to convert that into Kelvin, I simply add the number 273 to that, and I get 291 Kelvin. So there's my volume, pressure, and temperature. And it's asking me how many grams of methane, so grams of CH4. That's what I'm trying to figure out. Well, if you think about any of the gas laws that we look at, there's nothing that is related directly to mass. But in chemistry, the quantity, when we're looking at a quantity in a mathematical formula, we're going to be looking at the number of moles. So if you remember the ideal gas law, which you must memorize if you're studying chemistry, which is PV is equal to nRT. I have my temperature, I have my pressure, and I have my volume. R is a constant. So if I can determine N, if I can determine the number of moles of methane, well, that's not the answer. That doesn't tell me the number of grams. But if I go to the periodic table and I add up the mass of 1 carbon atom and 4 hydrogen atoms, then I obtain the molar mass of methane, which I already calculated as 16.04 grams in 1 mole. So there you go. If I can figure out the number of moles of methane and multiply that by the molar mass, then moles and moles will cancel out and I will get the number of grams of methane. So let's rearrange the formula of the ideal gas law to solve for the number of moles of methane. So I am just going to use my eraser here to erase this, and I'll say the number of moles of methane is going to be equal to PV divided by RT. So I'm going to put in my pressure, which is 3.289 atmospheres. My volume, 2.00 liters. Oops, that doesn't look right. Divided by the gas constant, which is 0.0821 liters atmosphere per mole Kelvin. And then I multiply that by my temperature in, again, Kelvin, 291 K. Now look, if you examine the units here, you can see the atmospheres and atmospheres cancel out with the gas constant, as do liters and liters, and Kelvin and Kelvin. So I'm left over with moles in the denominator of the denominator, which is going to bring them back up as a numerator, and I get 0.275 moles of methane. So that's how many moles of methane I'm going to obtain. But I want to figure out the mass of methane. So if I take my 0.275 moles of methane and I multiply it by the molar mass of methane, which is 16.04 grams of methane in 1 mole of methane, you can see that moles of methane are going to cancel out, and what I'm left over with will be the mass in grams of methane, which happens to be 4.41 grams of methane. There we go. So again, this question deals with the ideal gas law. It's a very good idea to commit the ideal gas law to memory. So PV is equal to nRT. It's a good idea to know that, to know when to use it, to know how to use it. And also in this question, you have to have a little bit of foresight in understanding that when it's asking for the grams of methane, the first thing you're going to have to do is calculate the number of moles of methane and then finally convert it into the number of grams of methane using the molar mass in the final step. So I hope you find this question and solution helpful.